feels illegal in math, but really isn't.
This epic and elegant solution to the following penny problem. Imagine you've got 50 penny rolls, each containing 50 coins. You know that one of these 50 penny rolls is fake, and your job is to figure out which one. Now, since the fake pennies weigh 2.5 grams compared to the real ones, which weigh 3 grams each, one way is to weigh each penny roll, which means you'll have to make 50 measurements. But can we do any better? One way is to split them in 5 groups and weigh each of them. The lightest group will contain the fake penny roll. So then after weighing the 10 penny rolls in that group, you would know which one is the fake one. This time it took 15 measurements. But what if I told you that there's a way to do this with just one measurement? That's right, just one. So before I make the solution video, I want to hear what your ideas are in the comments. This is one of the reasons why I absolutely love math. Because in math, you can come up with elegant and creative solutions which you thought were impossible.
No need to wait for part 2. The solution is coming up right after this, and if you like it, please follow for more math.
So I'll start by modifying the problem a little bit. Instead of having 50 penny rolls, we'll change it to 3. I'm doing this so that we can understand the logic clearly, and the same logic in fact applies to the more complicated problem. So say you have 3 penny rolls and one of them is a fake. So the question is, how do we weigh them only once and use that mass to figure out which penny roll is the fake one? The idea is that from the first penny roll you take 1 penny. From the second penny roll you take 2 pennies. From the third penny roll you take 3 pennies. Although I'm no artist, what I hope to communicate is that pennies from the same roll are in one stack. And the rings tell you the number of pennies. So in this case we've got 6 altogether. And since the real ones weigh 3 grams each, if all of these 6 pennies were real, then they would weigh 18 grams. But obviously they would weigh less because one of these penny rolls is fake. Since the fake pennies weigh 2.5 grams, if the first one was fake, then your total mass would be off by 0.5 grams because we had only 1 penny from the first penny roll. If the second one was fake, then your mass would be 17 grams because there are 2 pennies from the second penny roll, so you would be off by 1 gram. If the third penny roll is fake, then your mass would be 16.5 grams because we have 3 pennies from the third penny roll. So this way you can relate the mass directly with the penny rolls. And after weighing it only once, you would know exactly which penny roll is the fake one. Same logic applies even when you have 50 penny rolls. You take 1 penny from the first roll, 2 pennies from the second roll, and so on all the way to the 50th penny roll. So to find the total number of pennies, you have to sum numbers from 1 to 50. But since the 80-year-old Gauss was so awesome, he showed us an easy formula to make that calculation. So we can easily figure out that there is 1,275 pennies, and if they were all real, they should weigh 3825 grams. So say your weight was off by 3 grams. That means that 6 pennies were fake. So the 6th penny roll is the fake one. So to simplify, take the difference, multiply it by 2, and it will tell you exactly which penny roll was the fake one. And you only had to weigh them once.